Good morning, all of you. Myself, Dr. Vinay Raj. So today we are going to understand about big data, and then we'll talk about Hadoop, what is Hadoop, and its two important components, HDFS and MapReduce, and then we'll see demo with Amazon Elastic MapReduce, a very powerful tool what we have today for executing the Hadoop or the big data processing, right? So let's try to understand the importance of this topic, right? If you see a report by World Economic Forum, right, recently it has been published. So Future of Job Survey 2024. If you see this, I will just highlight you one part here. If you see this one, the highlighted one here, right? So core skills in 2030. Okay, so you see here expected to increase in importance. We already know AI is trending, but along with that, the one what is mentioned here is big data. So we are going to talk about big data today. This slide or this one graph, it tells us that how important this big data is and how much relevant or demand it has in the industry. Okay, so you definitely have to follow such kind of surveys what we are getting published in so many important by different companies, right? So this one is one. If you see the other skills here, right, creative thinking, analytical thinking, right, talent management, lifelong learning, okay, these things fall in the highest category, right? If you see the percentage wise here, and also the increasing share of employees, if you see, most of the people or the most trending skill what we are having today is one, AI and big data. You all have to have good knowledge on these things. AI, though it is trending and it has been fully occupied in our day-to-day life, still we need to explore more of AI and also about the big data, right? So this one slide I just want to show you so that you understand what is the importance of today's discussion. Now, data all around. Okay. The biggest problem what we are having today is full data is being generated. Okay, so full of data is generated, and lot of agencies or lot of IT industries or IT firms are storing that data, right? We know when you go to a mall, you give you fill some form, you give your mobile number, immediately you keep getting calls and messages, right? So data is everywhere and it is increasing like anything. I will show you some statistics about the data, right? So why we need to understand this? Because when can we define a big data? Where is this Hadoop coming into picture, or that MapReduce coming into picture of this situation? So we are getting data from social media, right? All your likes, dislikes, your comments, your uploads, your tweets, everything is stored. Whatever you are doing in social media, everything is being stored. So we have social media data. And next kind of data what we have, machine data. Lot of IoT devices are being used in today's electronic equipments, or in every aspect of our, if you see smart home, you know, lot of sensors are being used, and every sensor is continuously generating data. So that data is also being generated and produced continuously. So it is being collected and stored. It is being collected and warehoused. Warehousing means you are storing it in the some database or data lake, right? So industrial equipment or like IoT, it is growing like anything exponentially, and the data is being generated continuously. Okay, the third one is transactional data, right? You do lot of transactions, every transaction they have to store. After UPI has come, you know, even for 5 rupees, 10 rupees, 2 rupees, we are doing UPI transactions. So all those transactions are being stored. If you see, in India we have full population, everybody is using UPI, and on average if they do 10, 20 or 30 transactions, for each candidate, single person having single account doing this many transactions, you assume of the whole India, right? So full of transaction data is also being generated. Okay, so financial transaction, bank, credit card transactions, e-commerce, you are booking something in Amazon, Flipkart, you are purchasing, right? Everything, the data is being stored. Okay, we'll see some fun facts, what all data is being stored, what transactions we do, because of which the data is being generated, right? And we have different forms of data. Data is in form of table, it's in text, it is in XML, graph data, and so on. There are so many kinds of data. So the point here is to say that data is everywhere. Data is growing like anything, right? So where is this data coming from? Okay, see, every interaction you do with your mobile phone creates data. Every interaction with social media you do, it creates data. You are using Instagram, you are using Snap, it creates data. You are uploading pictures in Snap, simply it creates data, right? It is believed that in I think in 2024, there is one statistics in 2024, in 1 minute 2 million snaps are uploaded on an average in 2024. In every minute this many snaps are being uploaded. Okay, so a huge data is being created, and that's what, see, every time you walk down the street with a phone in your pocket, it is also tracking your location through GPS. That is more data, right? You buy something using your contactless card, it's also data. You read an article online, it's also data. You play a song, watch a movie, do anything, it's all about data, right? So data is being generated like anything. Every entity, each person is having 1 or 2 mobile phones, they are having so many electronic gadgets, and the data is being generated like anything. Some statistics of last year. Okay, this is again, I just want to show you some population data, just to create an awareness how much data we are generating every day, right? So if you see the social media users itself, you see, right, 62.3% of world population, they are using social media, right? And in that you understand how much data is being generated, right? So using internet, if you see, 5.35 billion people are using the internet, right? So because of all these statistics, you are interacting, you are purchasing, you are making a transaction, you are doing some financial transaction, for everything, right? We are generating data like anything. Again, the fact for students, average time spent on internet is 6 hours 40 minutes, right? So maybe we have to look after this. That is okay. So one more metric on which is captured on 17 January 2025. If you see, in every minute of the day, right? If you see these numbers, 231 million mails are sent. Okay, in every minute of the day, 1 minute, this many mails are being sent. See, if you see YouTube videos watched, reading Yelp reviews, apps downloaded, okay, shopping online, 6 million. Every minute I am talking about. In the whole day, how much data is being generated, and all that data is being stored. People are doing business with that. We are aware of that. Companies are tracking your data, banks are tracking your transactions, everybody is monitoring on that. How do you think that much whole huge data is being taken care? How are they giving your preferences? How are they giving you offers? It's based on your transactions. Like this, there are millions of customers. You go to a supermarket, they say, they ask your mobile number always, and they say you have this many points which you can redeem. So they are storing data of every customer all over the world, and they are seeing their transactions, how many grocery what he is purchasing. Based on that, they are giving offers to us, right? So I think you got an awareness. Huge data we are generating. We ourselves individually are generating the data. Nobody else is doing it. We ourselves are generating the data, because we are using social media, we are using internet, we are doing transactions, right? Now, when there is such whole data, right, how do we actually understand that? Okay, I am running a business, I am running some bank, for example SBI. I want to give some offers to some employees, right? A student or a fresher joins a company, and he opens an SBI account. To attract them, or to do good business, we want to give some offers, 10% discount on maybe some products or some shopping, we want to give that. How do we give this? For some people we give 2%, for some we give 3%, or so on. We do it based on the transaction history. But I will have lot of transaction, I will have lot of customers. In India itself, I think some crores of people will have SBI account, for example, if I say, right? How does that banking system, or how does any IT firm is doing business, or is understanding the data? Lot of questions are there, right? So how do you draw meaningful patterns out of this data? Such huge data, how are our systems working automatically to understand. You see, you watch something in Instagram, you speak something outside, keep putting your phone aside, you will see those kind of reels on your Instagram feed, right? So it is listening, immediately giving recommendations to you. For individual, for you alone, it is not doing, it is doing for the every person who is using Instagram or any other relevant app, right? So how is this processing happening? Okay, these are the main important questions. That such large data is there, how are the organizations dealing with that, right? Such large data, we term it as big data, we call it as big data. Okay, so this, if you are processing this big data, small data is there. If I give a CSV file of data, or maybe with some 10K records, you can write some program, normal Java or Python program, to read this CSV file, read that content, load that into SQL table and do some processing, or into some NoSQL database, and you can do the processing. It is possible, right? But world full of, when you see this much of content, okay, this much of content is there, how do you store that data? Your tweets, you see, you are using Twitter, you are doing a tweet or you are doing a retweet, everything is stored. There are millions and millions of users of Twitter, right? So how is that data stored? So we are going to understand about one such concept of how do you process such large data in this today's session, right? We are going to understand that. So the term big data comes into picture. We call it as big data because it is big. But on what basis do we call it big data? Can I call a CSV file of 10K records as a big data? Yes or no? That we are going to see. We will try to understand that. When can you refer something as a big data? But the point here is processing such data, right? When you process such big data, only then you can derive some insights and solve the real world problems. Okay, so how do we do that? Let's go into this. Before I go into this, let me come back to here. One simple example of big data. When can you call a data as a big data? How do you classify it? Right? Suppose a simple example, we know we always use Gmail, and if you are attaching a 100 MB file, it will not be attached. It will take you to Google Drive, upload in the Google Drive, and then attach that link here. We know because the maximum limit is 25 MB, but I have a file of 100 MB. So it depends on the context. When do you call a data as big data? It depends on the context. Okay, so in this scenario, in this example, when I am talking about email, so when I have a 100 MB file to be attached and I have a limitation of 25 MB, then this 100 MB is a big data in this context. We can call something as a big data if it is beyond the capacity, right? There is already a system defined, it is working fine. Email, we are sending lot of emails every day, we do attachments and send, but if that size of that attachment is more than its limit, it becomes a big data. It means if your system is unable to handle data beyond its capacity, those kind of data we can refer as big data, right? Another example, right? I am playing with machine learning, I am doing some AI, I have 10 TB of images to be processed. I want to do some enhancement, I want to do some image classification, object detection, lot of algorithms on those images, right? So generally to handle this much 10 TB, I will not have space itself. My hard disk might be 2 TB or maybe 1 TB maximum space. Generally our systems or laptops what we use have this much capacity. How do I handle this? So it is beyond my system's capacity, it is beyond the capacity of my traditional system, right? Then we call that 10 TB data as big data. Okay, so this is just to tell you how do you differentiate, because it's a very popular question they ask you, how big is the big data, how big is it big, how do you quantify it as big, right? There is no such number, it depends on the context, it depends on the system. You can use this email example or this storing of images of 10 TB data as an example, right? Now let us come back to big data. So how do we know? Again, there are some different version of big data. If you want to call something as big data, it should satisfy these 5 properties, very commonly known as 5 V's of big data. Again, this is also one of the popular and important concepts when you learn big data, right? So if any data which satisfies these properties, then we term, again this is very clear, but still these are few characteristics of big data. First one is volume. right? So the sheer amount of data, volume means the amount of data. We talk about terabyte, petabyte, exabyte, right? We talk about all those things. If it can fit in your spreadsheet, you might enter into big data. You are having some data in a small Excel sheet, the data is not fitting, then you can call it as no big data. The point number one, volume, it talks about the amount of data, right? Next is velocity, the speed at which the data is generated and processed. Okay, so data is generating and like anything. Best example is IoT. You know, IoT is continuously every minute or 30 seconds we are generating 1 0 or 1 0 1 0 1 0 0 0 1 1 1 something. This kind of I am talking about a base case again, simple example, right? Some sensor is sending triggers to me, it is sending data to me continuously. So velocity means the speed at which the data is being generated. Variety, we have different formats, very very important, different formats of data, structured, unstructured and semi-structured data, right? So again, when we talk about structured data, we can store structured data in SQL tables. When you have semi-structured, unstructured data, you can store the data in NoSQL databases, NoSQL tables, right? Something like JSON format. Okay, so this is about the variety of data what we are having. Then veracity, right? Veracity again, uncertainty means there are some missing data, there are some junk values in the data, right? Some maybe for example, I have a column maybe marks with 100. For a student, marks this in this column 100 means it this could be a valid mark, 45 could be a valid mark, 98 could be a valid mark, but if there is -10, it is invalid. There is 105, it is invalid, right? Sometimes in place of this 2, I might have hash like this. So we may have a lot of junk data. So in big data, one more property is veracity, the uncertainty and trustworthiness of the data, right? So then the last one is value, right? The important value means again I am using this big data to derive insights, to find out, to identify some patterns in that data, how the customers are making transactions. Based on that, I want to do some business, right? So for that, the potential insights and the business impact hidden in the data is called value, right? If the, see, I have somebody gives me some data and says that no, this is the transaction data of 1 month transaction data of some government employees, for example, if they say this, right? So they want to give some offer to the government employees, and if the data is not really of government employees, that again that has no value of deriving the insights, right? So these are 5 very important properties linked with big data, right? Volume, velocity, variety, veracity and value. But however, I hope you understood the context. The size, how big is the big data, it depends on the context. You have to validate it with the examples, right? Now when I have such huge data, right, I am having such huge data with me, how do I process it? The main job or the task of today's discussion is about processing it, understanding that data. Okay, so understanding and deriving some insights, it means first I have to understand what is there in the data, I have to process the data. Traditional way of doing, okay, maybe I'm talking generally, what we generally do, okay, there is a CSV file or let's say no, I'm having some images with me, right? These images, if I use some traditional system, right, for me to run, for me to execute and identify some pattern from these images, it will take days for me. It will take so many days, 10, 15, 20 or 1 month it can take to have to play with such 10 TB data, even if I have such storage, right? So in traditional approach, data is generated out of organization, financial institutions, banks, stock market, all these things are given to ETL system, extract, transform and load, extract, transform and load, and that is being stored into database, right? So based on that, we do the querying of the data. Once the data is stored in the database, then we write some SQL queries and we try to generate reports or perform some analytics, derive some insights from that data, right? But how long can you do that? It is very very challenging task. If the data is small, that is okay, but if the data is very high, it becomes a very, very challenging task to manage and process the data, right? So this is the drawback. No, why? Okay, I am talking about the point Hadoop actually. I am having big data with me, right? Normal system cannot do that for me. Okay, when I have a normal system, it cannot help me, or a traditional approach of understanding that big data and deriving insights or generating some reports is difficult for us. We cannot do that, right? So what is that one concept, or what is this, what is the one which can help us to process this very easily? There are so many such approaches, and one among them is Hadoop. Okay, so let's understand the tools. There are so many such tools. One is Hadoop. There are Spark, Kafka, MongoDB, Tableau, Power BI. So many things exist which can help us in processing the big data. Again, when you have large data, it could be Twitter data, tweets data, or it could be Snap data with us, right? Or it could be banking transaction data. How do we understand the data? How do we learn or study about the data so that we can do good business, right? I am talking in the sense of IT firms or organizations or companies. Some SBI want to do some business, they are doing anyhow. So there are so many such firms who are doing business, but how do they understand the patterns? For that, we have to process that big data. Means we have to understand each part of the data. So there are so many tools which can help us for doing this big data analytics, and one among them is Apache Hadoop, right? So it's a framework that allows for the distributed processing of large data sets, right? So it follows some separate style. Okay, instead of, no, when I have 10 TB, with me and you have one system with you, you are giving this, transferring those data into this system, and you have written a program here, right? So this program is taking one image, doing some processing, storing it in the another folder, taking another image, processing it, storing it in another folder. Like this it works. I am saying this process will take so much of time, and I need a very good or high end system. We need something like supercomputer to do this job for me, because taking images, doing transaction, taking again sending, taking again sending, it might take a lot of time, and we should have some very good configuration of the system, right? So Hadoop is one which can help us by performing the distributed processing for large data, right? So it is designed to scale up from a single server to thousands of machines. Okay, that is the actual flavor, or I will say the running principle behind Hadoop. What it does, it will take from one system, it will scale up multiple systems, right? It will give that job to multiple systems and ask them to do. That is the one important feature. We will try to explore about that, but let's see the other tools what we have. Then we have Spark. It's an open source. Same thing for that. The Spark is known for speed and ease of use. Okay, both are same. Again, Hadoop you can use, Spark you can use, or even Kafka you can use, right? So MongoDB is one NoSQL database. This is a data storage. I will not say that to store that unstructured data we have to go for NoSQL, right? MongoDB. And Tableau is for visualization part. You have that big data, it can visualize and show you, understand that data. It will take whole data, understand the data, and show you some statistics. It will show some dashboards. It will give you some visualization about types or other features of that particular data. Maybe it contains date range. So 2022, how many transactions were done? 23, how many transactions were done? All that I can visualize in using Tableau. Like Tableau, we have Power BI also, business intelligence tool, which also helps in playing with such large data. Okay, so before we move forward, so if you see the summary of that, I have said that huge data is being generated from different sources. We ourselves individually, we are generating, we are using, see, mobile phones people are using, internet people are using, and social media people are using, right? So huge data is being generated, and this is one scenario where how much of messages are being generated or data is being generated by us, right? So to derive patterns, we call such huge data as big data, and there are so many properties for big data, right? and we also understood that the big data, it is big. The term big depends on the context. Okay. So, the drawbacks in my traditional approach to perform the ETL operations, it is challenging because we do not have that much capacity or the systems to perform such operations, right. So, when the data is huge, I cannot do it in my traditional systems, and there are so many such tools. One among them is Hadoop, is what we are going to learn today. So, you got an awareness of what from where the data is coming and how big is the data, and what is the current problem what we are facing, how to overcome that, right. So, managing or processing, understanding this huge data is problematic. So, we go for some frameworks like Hadoop. Okay. So, let us try to understand what is Hadoop.